And we've got exercise 2B parallel lines today. So parallel lines, we know that they look like this. So two straight lines that run in the same direction, and how we indicate that they are parallel is we use arrows. Sometimes the arrows are drawn in the center of the line, but those arrows mean that it's parallel. So if you don't see those two arrows, it means it's not parallel. Okay? So now that I've got two parallel lines, does anyone know the line that crosses through the two parallel lines? Does anyone know what that is called? It starts with T.
Is it like transversal or something?
Yes, it is called the transversal line. Write it in if you didn't know, because I'm going to use that language. It's called the transversal line. So any line that cuts through two parallel lines is considered a transversal line. And in fact, you've probably seen it already, say with a rectangle. See, when you draw a rectangle, say this is one side, the length of a rectangle, those two are parallel. And then you have the other side that makes the 90 degrees of a rectangle. That technically, those two are your transversal lines. See that line and this line? Those two lines, that line there is a transversal line, that line there is also a transversal line. So that's a transversal line. And that's a transversal line. And so therefore the properties that we are going to identify also fits with four-sided shapes or five-sided shapes, six-sided shapes. It's as long as it's parallel. Okay? Now, there are four key properties that you must know, and the two key skills that you take out of exercise 2B is, number one, you have to be able to identify them. Okay? Here are the four. You've got corresponding angles. The next one is called co-interior. Co-interior angles. Then you have alternate angles, and the last one you've already seen from yesterday, starting with V. Anyone remember what V might stand for? Yes, Elijah? Vertically opposite. Very good. Okay, so we've got four key angles, and when I was coming up with a way to teach the students, when I first started teaching, I taught them the F way, and then the Z way, and the C way, but I just found that even after like a week or even a session, students just forgot the whole thing. But when I went through this way, I found the students tend to remember it. So this is what I noticed in the four key letterings that they have to remember. Notice that co-interior and corresponding, they have the same letter. True? Whereas alternating and vertically opposite, they have different letters. True? And then I realized something was interesting, is that when we do corresponding and co-interior, not only do they have the same, I'll do a color coding, not only do they have the same letter, they also have something similar to start off with to help students figure out which one it is. So this is how I teach them. Write in the same column, under the column same, write corresponding for the top one. So this is corresponding angle. And just underneath it we have, this is co-interior. So why is it under the same column? Not just because the letter is the same. The actual thing that actually I realized that separates them is this. So if I draw a transversal line, right? So you got two parallel lines and you got a transversal line. It cuts the parallel lines into two regions, the left side and the right side. True? So same thing with the co-interior. If I drew a transversal line, it separates into left side, right side. And what I realized is that co-interior and corresponding, the two angles that we look at actually have to be on the same side. So what do I mean by that? Here we go. I'll show you an example. Co-interior is one of the easiest ones to remember, so I'll start off with this one. Co-interior, let's break it up. What does interior mean? Yes, Aaron? Inside. Okay, so it has to be inside, right? And what does co mean? So think about co-teaching, collaborate, cooperate, co-parenting, coordinate. What does the co actually mean? Does anyone know? Together. That was the key word. So this is saying, you said interior means inside, co means together. So both of them together have to be in the inside. So what we're talking about, inside what? Well, can you see the two parallel lines? If I highlight it, there's the inside of the parallel lines. So between them, that's the inside. And then there's the outside. See, that's the outside. Outside parallel lines, yeah? So what this is saying is, for it to be co-interior, they both need to be on the inside. See that? These two angles, so that angle there is on the right-hand side, but the other angle also has to be on the same side. So it has to be on the right-hand side as well, but also has to be inside. So there are two things that you can write here. They need to be on the same side, so they're both on the right, and they both need to be inside the parallel lines. If that ticks off the case, if that is true, if they're both on the same side and they're both inside the parallel lines, we call this co-interior. Now there is another one. So the right-hand side, we can pick these two angles are inside the parallel lines. But if I pick the left-hand side, I also have another pair of co-interior angles. That blue angle here, the acute angle, and then this obtuse angle, the blue one, these two are considered co-interior as well. Okay, so the red one, the pink one is co-interior, and the blue one is also considered co-interior. But what patterns did I notice when I was formulating this table? I realized corresponding co-interior, they both have to be on the same side. So the two angles have to be on the same side. They both have the same letters, and for co-interior, both angles have to be inside. I was like, oh, that's easy for kids to remember, because they just look for, if they know the two angles on the same side, well then, which out of the four have the same letters? So the corresponding or co-interior. So it narrows from 4 options down to 2 options. Okay, it makes it 50-50 of them getting it right. All right. Now, one thing that students will forget generally about co-interior angles, have you noticed that the angles, one is an obtuse, and one is an acute. So that means they can't be the same. True? Because one's bigger than the other, right? So on the bottom here, what we realize in mathematics, there is a proof to it, but for now we're just going to stick to this concept. It is co-interior, then both angles are supplementary. Now, yesterday I mentioned about this term. What does supplementary mean again? Yes, Will? Very good. So whatever these two angles are, this obtuse angle, let's say it was 150 degrees, then that means this angle on the bottom must be what? What should this angle be? If this is 150 for the obtuse, what would the acute one have to be? 30, because it has to be supplementary. Okay, so they have to add up to 180 because these two are co-interior. But what's interesting is if this is 150 up here, what's the blue one, the acute angle for the blue one? What must that one be? 30. Why is this one 30 degrees? Can someone explain? Why is this definitely 30? If this is 150 over here, why is this 30? Elijah. It is a parallel. So this is a nice straight line. And what did we learn yesterday? In a straight line, the angles are 180. So that means in a straight line, the angle from here to here has to add up to 180. It's a semicircle. So if this is 150, this one has to be 30 to make it 180. Okay? So then again, using that same concept, if you know this is 30, well, what should this one be? Based on the fact that they're co-interior. 150. That's one of the special things about co-interiors. Okay, so they have to add up to 180. So fill in those notes for co-interior. So co-interior, how do you know if it's co-interior? Pick 2 angles. Are they both on the same side of the transversal line? If it's yes, then you have 2 options. It could be corresponding or co-interior. Then the next question is, are the 2 angles inside the parallel lines or not? If they're both inside, it must be co-interior. But if it is co-interior, they have to add up to 180. So far, so good? All right, let's go back up then. So if that's co-interior, and that was the easier one to identify, then let's have a look at corresponding. So corresponding, same thing. They need to have, those 2 angles need to be, again, on the same side. Okay, so they have the same letters, they're in the same column, and therefore the two angles have to be on the same side of the transversal line. So here's an example. I can draw an angle up here. Now I call this top. Why do I call that top? Because this is your first line. True? You see how it's sitting on top of that straight line? Yeah? So it's sitting on top of that straight line. Now, in order to have a corresponding angle, corresponding means whatever one does, the other one does the same. That's corresponding. Yeah? So if this is the first line and the angle sitting on top, then this is the second line. The angle must also copy that and sit on top. But can you see how they're both on the right-hand side of the transversal line? So it's on the same side of the transversal line. And then on my notes here, I wrote top with top. So top goes with top because they have to correspond. Therefore, bottom, but with bottom. Very good. So let's draw a few more. Now that you've drawn that, let's draw a few more possible corresponding angles. You see, it didn't have to be the right-hand side. I could have picked a bottom one. So I could have done this. I could have picked an angle on the left-hand side. See how it's on the left-hand side of the transversal line? That's one angle. Now, if I want a corresponding angle, if this is on the bottom of the first line, then it has to also be on the bottom of the second line. This is called corresponding. Okay? There are technically another two corresponding angles. See if you can see it. So I'm going to draw it in. See, on the left side, I could also say this angle here is on the top of the second line. For it to be corresponding, it needs to also be on the top of the first line. So I've got three colors there. I've got pink, orange, blue. There are three pairs of angles that are corresponding. And the last one, obviously, is, I'm going to do it in green then. This one's on the bottom, but on the right-hand side. Therefore, this one needs to be also on the bottom of the right-hand side. That, bottom with bottom, these two pairs are corresponding. These two pairs, the pink ones, top with top, those are corresponding. The orange ones, top with top, those are corresponding. And then lastly, bottom with bottom in blue, those two are also corresponding. Does that make sense? Yeah? So if I zoom out now, you see the four that you have to memorize, corresponding, co-interior, alternate, vertically opposite, you start off with by asking yourself the first question. Are the two angles you're looking at on the same side of the transversal line? Because if they are, you only got two options. It's either co-interior or corresponding. You don't have to worry about alternate or vertically opposite. So that's the very first question you ask yourself. Are the two angles on the same side? Yeah? All right. Now, if they are corresponding, then both angles are the same, which logically makes sense as well. So for example, if you look at this one, if I wrote bottom, if I said this was 150 degrees, this one has to be 150 degrees again. Why? Have you noticed that the shape from here to here is actually symmetrical to this one? It's almost like if I cut this in half, took the bottom bit, it should match the top bit. And in fact, that's how your chairs are built. You see your chairs, these angles here, if you have a look at it, that angle of those legs, they have to be exactly the same angles as all the other legs of the other chairs. That's why they naturally sit right on top of each other. That's why they're parallel, because they're sitting, oh sorry, let me draw it again. Each chair has to sit exactly on top of each other. So they have to be parallel. So the angles all have to be the same. So if you know one angle, the other one has to be the same. That's how the chairs are built. They're all parallel. Yeah, so they run with each other. Each leg is parallel with each other. That's why it stacks perfectly. It just keeps going up. Yeah? All right. There we go. So angles for corresponding is the same. Co-interior is the only special one where they have to add up to 180. The rest is all going to be the same angles. Okay? All right, let's pick another easy one. So you've now ticked off 50% of the things you have to memorize. The last two, alternate versus vertically opposite, have you noticed again? Letters are different. And I put them in the different column. Why in the different column? Because I noticed there's a pattern. Let's draw a transversal line. And let's draw a transversal line for this one as well. On the bottom, it's the vertically opposite. So on the bottom, it's vertically opposite. And the top one is going to be alternate. Out of the two, you guys have already seen vertically opposite. So let's look at that again. Okay, so vertically opposite, so alternate, vertically opposite. Let's have a look at vertically opposite. Let's zoom in. I'm going to do the same thing again. This is 150 degrees, so from here to here, that's obtuse. Let's call it 150. Where is it going to be vertically opposite? Now, there are two common mistakes that I see students do here. Some students will tell me this is 150 and vertically opposite. And then some students will tell me this is 150 that's vertically opposite. And some students will also tell me this is 150 vertically opposite. Now I'm going to name them 1, 2, and 3. Hands up for number 1 as vertically opposite. Okay, we've got one person. Hands up for number 2 as vertically opposite. Okay, we've got 1, 2, 3, 4, 5, 6, 7. So we've got 7 here and about 1 or 2. And then hands up for those who think number 3 is vertically opposite. No one? Okay. And the rest is unsure. Okay, cool. So, which one is the correct answer? 1. Now, how do you know? Now, let's go back to yesterday's lesson. Yesterday's lesson, we drew a line. And you told me, what's the angle in a straight line again? 180. But then I can split that line. Watch me split it. I'm going to split it like this. Okay, I'm going to cut it like that. And let's say if this was 150 on this side, from here to here, what would this angle have to be over here? 30. Okay, so you guys knew that. Then we extend that green line. Let's extend the green line, because that's what you guys are sort of seeing. We're going to extend that green line. Now, if I cut it through, this is where we ask ourselves which one's vertically opposite, right? But you see a pattern. If the red line was a straight line, it's 180, then the green line also has to be 182, right? From here to here has to add up to 180. So if this is 150, what would the angle over here have to be? 30. But then if that is true, that makes a straight line. If this is 30, then this one over here has to be. Okay. Now I want you to zoom out and look. Do you see why number 1 and number 1 was the correct answer? Because it's where the two lines intersect. It's based on two straight lines. These are the two straight lines. See the cross? There's a cross here and there's a cross there. Number 1 had to be the correct answer. Why is number 2 not correct? They're on two different crosses. But the most common answer, which that number 2 and number 3, is what I see students do when I do it in a parallel. But if I did it like this, all of you would get it right. I do it like this, and I get students getting 2 and 3. And that's what I'm trying to say. It's that understanding. It's the intersection between two straight lines, why that is true, why that works. Make sense? Okay, so number 1, this is 150, that's 150, but I'm not saying this is not correct. It is 150 degrees as well, but it's a different name. It's not vertically opposite. This is actually alternate angles, which I'll teach next. Right now, these two are vertically opposite. And this is obviously the one that was absolutely wrong, because clearly it's an acute angle. That's obtuse, that's obtuse, that's obtuse. So this is vertically opposite. These two are vertically opposite. Okay, so 30 and 30. And then 150 over here. This is also 150. Those two on the bottom, so I'm going to highlight it in blue. This one and this one are vertically opposite. Find the intersection. So let's write our notes. Have you noticed that the vertically opposite angles, one is always on the left of the transversal line and one is always on the right. It's not on the same side. That's why I wrote here, different sides. So as soon as you see two angles on different sides, you only got two possibilities. It's alternate or vertically opposite. It can't be co-interior and it can't be corresponding because it had to be on different sides. So different sides, you could have vertically opposite, but what else did we also know? It's where both lines intersect. It's where they both cross. So you find that cross, just keep finding the cross, and then you find all the vertically opposites. Opposite angles are the same. And here we go. If it is vertically opposite, then both angles are the same. There we go. Okay, so that was linking exercise 2A with today, which is 2B. And the final part in our theory, like I said, 2B is the hardest one to get your head around first. After you apply a couple of times, you start to reason it. Here's the last one. Alternate angles. Okay, I'm going to give you all the angles that are alternate. Let's see if you can see it. So, number one, they both have to be on different sides. Okay, so here's an angle that's on a different side. So here's angle. Now for alternate, I try to make it similar to corresponding. So corresponding with top, bottom with bottom, right? This time, to help your memory, I wrote outside with outside. And inside with inside. What does that mean? So remember I told you inside is the two parallel lines, the space in between them, that's inside. Anything that's not inside is on the outside. Cool? So now, if I pick this angle, is that on the outside or on the inside of the parallel lines? Outside. So we say, okay, this is outside. That's on the right side at the moment. So for it to be alternate, it has to be, the other one has to be on the left. Okay? But it has to be on the left and on the outside. So if it's on the left, there are two parts that could be outside. So it could be this one. It could be this one. Only one of them is correct. Let's label it again. This is number one, number two. Hands up for number one. Hands up for number two. That's correct. Now, why isn't it number one? Give me a reason. Beautiful, because it's already got a name. We already knew that's where the cross intersection is. These two are actually equal and they're vertically opposite. So that's not alternate. This is alternate. Okay? So very good that you picked up on that. And you were able to reason it as well. Well done. So, outside, this is alternate. Let's pick another one. I can do another one that's inside. So let's pick on the left side. Let's say I pick this angle. That angle there. Is that one on the inside or outside? Inside. And notice it's on the left. So that means the second angle has to also be on the inside, but on the right-hand side now. Now there's two possible options. There's this one and there's this one. Number one or number two? Hands up for number one. Hands up for number two. And then the rest is unsure. Okay, so most of you got number two, and the answer is definitely number two, but I'm more interested, why is number one not true? Because it fits our definition. It's one on the left, one on the right, so it's different sides. And it is inside. What's wrong with number one?
I think if number one was there, and then it'll create a full circle, which is vertically opposite.
Ooh, not vertical opposite.
What's the word for it? I know what I'm thinking. I just don't know how to explain it.
Okay, I think you're almost there, but you're right. There's something about this. We do have a name for this. What's a name for this? It's not vertically opposite, because vertical opposite is the red and the blue one. What is these two together? What's the name for that? Anyone see? Harley?
Supplementary.
Yeah. That's a straight line. Have you noticed? This is your parallel line, which is what Aaron was trying to say. This is a parallel line. That there plus this one, if it's a straight line, what is it meant to add up to? 180. It's a straight line angle. So we already got a name for it. This is straight line, or you can say it's supplementary. We already have a name. Doesn't need a new name. These two is special. These two are actually equal to each other, and they have a special name, and they're called alternate. And you can kind of see it when I did it over here before. Have you noticed? When I did this and I was showing you co-interior, have you noticed that these two See that? I've proven 30 and 30, those two angles are the same. But they're alternate because one's on the left, one's on the right, and both of them are inside. Same thing with this one. This one is on the right, this one's on the left, and they're both inside. They're alternate. Okay, so if I zoom out, that's pretty much 2B. This is 2B in the first skill. Skill number 1 is for you to identify. Okay, so this is the theory. Now let's try to identify. So skill number 1 is to see if you can even identify the 4 types of parallel lines. Flip over the page. You can always refer to the notes, but let's look at number A. I want you to find the 2 parallel lines. So in your head, look at it. So here's my 2 parallel lines. Here's your transversal line. So separates it, yeah, into one region and the other region. First question is, are the 2 angles A and B on the same side of the transversal line or not? Yes or no? Is A and B on the same side of the transversal line? Hands up for same. Got 1, 2. Hands up for different. 1, 2 as well, and the rest must be unsure. Even though I tilted this diagram, if you look at it, I've cut the parallel lines here. So it's got this side and then this side. It doesn't have to be right and left, it could be top and bottom. A and B clearly sit above. So they're on the same side. Now if they're the same side, which 2 possible properties could it be? Out of the 4. So you had a corresponding co-interior, alternate, and vertically opposite. If they're on the same side, which 2 can it possibly be? Corresponding or? And one way to remember it is, if it's on the same side, they should have the same letters. And there's only 2 with the same letters, C and C, co-interior or corresponding. The question is, which one is it? Is it corresponding, which I'll call number 1, or is it co-interior? And to figure it out, co-interior is the easiest one to figure out because co-interior, you just look if the 2 angles are inside the parallel line. So let's have a look. Here's your blue. Inside must be between the 2 lines. Is A on the inside? Yeah, it is. It's between the 2 lines. Is B on the inside? No. So it can't be co-interior already because we said the co-interior means both of them have to be on the inside and they both have to be on the same side of the transversal line. So it can't be co-interior. Don't straight away jump to corresponding because we don't know yet. So let's test it. They're both on the same side. For it to be corresponding, it's top with top, bottom with bottom, right? So if you tilt your head, try tilting your head and look at it this way so it's a bit more familiar for you. If you look at A, can you see this is the first line? It's on the right-hand side or on the bottom of the first line. Is B the same? Yeah. It's also sitting on the second line. It's sitting below. So you can have the angle above. You can have the angle above as well. So that's bottom and bottom. So it means that these 2 are the same angles. So it's doing the same. It's corresponding the same way. So it must be corresponding. So those 2 students who thought it was corresponding, well done. That means A and B are equivalent. Whatever angle A is, if this was 30 degrees, this one is also 30 degrees. And the reasoning for it is because they're both corresponding. Have a look at B. I'm going to pause for a second, get you to think. So ask yourself, is the angle A and the angle B on the same side of the transversal line or not? If they're on the same side, it can only be corresponding or co-interior. If they're not on the same side, it can only be alternate or vertically opposite. Okay, not on the same side. So Aaron recognizes that A is on the left and B is on the right. So clearly it can only be either alternate or vertically opposite. Vertically opposite is the easiest one to find because you just find the intersection of 2 straight lines. Here's my intersection of the 2 lines. Here's my intersection of the 2 lines. A is sitting on this cross. B is sitting on that cross. So clearly it cannot be vertically opposite because they're not on the same cross. So clearly we can cross this off. It might be alternate. You got to check. Now remember, alternate is similar to corresponding. Instead of top with top, bottom with bottom, it is Outside with? Outside, good, and inside with inside. Very good. So let's have a look at the angles. Is A outside or inside the parallel lines? Inside. We can see that these are your two parallel lines, and in between them, that's the inside, right? And we can see that A is on the inside. Is B also in the inside? Yes. So it must be alternate. Okay, so this must be alternate. It's not the supplementary straight line. If it was over here, that's not alternate. That's a straight line. A plus B makes 180, right? But this, and another way to know if it's true, have you noticed A over here, that's an obtuse angle. This is an acute angle. Can't be the same. They're different. Yeah? Whereas B, these two are both obtuse. So of course they're the same. And alternate angles have to be the same. Yeah? All right, good. So that's alternate. Here's the last one. Pause. Have a think. Ooh. Oliver's already got the answer. Oliver, what do you think this is? Co-interior. Can I get a show of hands who also think it's co-interior? 1, 2, 3, 4, 5, 6, 7, 8, and the others may be unsure. The answer is co-interior. That is correct. And again, same thing. Two parallel lines. Here's a transversal line. And you ask yourself, is A and B on the same side? Yes, they are. They're both on the top. And are they both inside? Yes, they are. They're inside the two parallel lines. So if they're both inside and they're both on the same side, it must be co-interior. But remember, co-interior has a special property. A and B doesn't equal each other. A and B adds up to 180. So just remember, if it's co-interior, they're supplementary. They have to add up to 180. Okay? And you can tell by looking at the graph. One is an acute angle, one's an obtuse. How can they be the same? Doesn't make sense. Okay? All right. That was skill number 1. So part of the exercise, the first part is, can you identify? That's probably one of the first steps. The second one, some of you may find the second skill a bit easier because you kind of know it intuitively, but you might not be able to reason why. Okay, so most students who do and solve this, they can solve it, but if I ask them why is it this number, they don't know. And that's a problem because when it gets more complicated, like this one, I'm going to show you, that one, if you don't have your theory strong enough, then you're unsure if your answers are correct. I know it looks complicated, but your skill here is to look for two angles. Each time you break it apart, look for two angles. So like for me, I look at this and I say, two parallel lines because of the arrows. Here's a transversal line. And that 146, I can say a couple things. If this is 146, that's on the left side. And that means this entire angle over here, which has to be the right side. See how this is inside, inside? If they're inside, they're alternate. So if that's 146, this entire angle over here has to be 146, but you already know this is 110. And you can work out, well, yeah, you can add, that's A must be 36. But you can see how I chose two angles, and I just used one of the properties. The reason why this becomes tricky for students is because their theory is not as strong. They can't identify yet. So skill number 1 is to learn to identify in a mixture of things. And you can see the way the questions set it up for you. They set it up pretty straightforward, getting you to label. Then they get you to find multiple angles, and there's still parallel lines there. Then they give you shapes that you've seen, like parallelograms, triangles. Then they mix them. They mix it over here. They give you unconventional shapes that you still have to be identify, and then finally you put them all together and you get that. Okay, so build up your skills. So here we go. Let's go back to the problem. Here's your last one. I'll do this one, and I'll leave B for you to try, and then I'll write the solutions up. But here we go. Let's look at this. A. I'm going to choose 70 because 70 is meant to tell us something already. So I've got this angle. Here's your two parallel lines. Let's find A. So if I do 70 and A, let's go through the same questions. 70 and A, they're two angles. Are they on the same side or different side of the transversal line? Same. Yeah, they're both on the right. They're both on the right-hand side. So this angle, this is the transversal line, cuts it in half. That's the right, that's the right. So if it's on the same side, there's only two types that it can be. Co-interior or corresponding. Is it co-interior? No, because they're both not inside. So it might be corresponding. Let's check. That's sitting on the top of the first line. This is also sitting top of the second line. So it must be corresponding. Now, if it's corresponding, what do we know? It's 70. You already said 70, and that is correct. So when you write 70, make sure when you're doing this exercise, draw the diagram. And if you did write A equals 70, write Y to remind yourself. Write corresponding. Because that means in 6 months' time, when you go back, you see the diagram and you revise, and you look at it, you remember why you wrote 70. Okay. Otherwise, if you just wrote 2A70, no one's going to remember what it is. Yeah? All right, let's pick the next one. I'm going to pick 70 again, but this time I'm going to do with B. Let's do it again. Is 70 and B on the same side or different side? Different side. So which two could it be? Or alternate. Very good. So you got two. You got alternate or vertically opposite. Vertically opposite is the easiest one to identify first. You look at 70 and B and you ask yourself, is it on the same cross or intersection? Is it? Here they are. See, the two angles belong on the same cross. They're not on different crosses. So they must be vertically opposite. Okay, so one's on the right, one's on the left. If this is 70, B must be 70 as well because it's vertically opposite. So when you write your answer, write B equals 70, but in this case it's vertically opposite. If you're too lazy to write vertically opposite, you can write V.O. And that means the same, as long as you know how to read it. So when you go back and you know that V.O means vertically opposite. And then finally, now there's a lot of ways to solve for C. Once you've got B and A, I mean, you could do a lot of things here. You could do A and C must add up to 180 because it's a straight line. What else can you do? So I just did A and C, and I said that this is a straight line. So they have to add up to 180. So if that's 70, the other one must be 110. What's another way? What's another way that you can see?
You can add 70 plus 70, which is 140, and then you multiply it, and you 160 minus 140, which is 220, and then you divide it by 2, which is 110.
Oh, I see what you're doing. That was creative. It took me a while to understand what you were saying. So 70 and 70. So 70 plus 70 is 140. And we know that this is a full circle. Full circle has a total angle of 360. Since this is C, this is also C. So since 140, 70 plus 70 is 140. You take 360 minus 140, which Lossalia said it was 220. And because these two are the same angles, she divided by 2. So 220 divided by 2 equals 110. That's one way of doing it. That's very good. What's another way? I'm still seeing another one. Another one that we can use the properties we learned today. Say. 70 plus? Yes, but what property are you using? Yes, supplementary. I'm actually looking at these two, B and C, which is supplementary. B and C is meant to add up to 180. Why? What's the name for B and C? Look at the angle of B and C, Shreya. They're co-interior. Have you noticed? B is on the left-hand side of the transversal line. C is also on the left-hand side. And they're both inside the parallel lines. So they're co-interior. And co-interior means if they both add up, they should add up to 180. So that's 70. That's 110. Can you see how I'm doing it? I'm identifying them. So there's lots of ways to solve it. And the same thing with the enrichment question. If you can work out many different ways to solve it, the better you can identify the four, the easier it is to solve. Cool? I'll stop there because that was a long session there. But like I said, this is the hardest exercise to take. It's okay to take your time. Remember, this is not due until week 7. I won't be checking until Wednesday of week 7. Obviously, next week we do C and D, but I'm just sort of telling you I won't check until week 7. So you got some time to learn this. It's week 5. Today's the end of week 5. Next week is week 6. All right, so let's stop there. Now,